Hello, Catskill High. Mr. Irvis here. We are 512 doing Algebra Unit 7B lessons 3 through 6. That was all the factoring. So you're going to see a lot of greatest common factor, DOPS, and unfoiling today. Some people say factoring trinomials, but it's all the same. So again, make sure you're on the right date, 512. And the first thing they ask us to do is factor out the greatest common factor, GCF is a shorter way to say it. And we say, think of it as reverse distributive property. That makes it a little nicer. So if this is reverse distributive property, that means when we're done, it's going to look like you should distribute. Well, we just looked at these two terms, and what is a number that divides into 4 and 12? Well, 2 divides into them both, but the greatest number you can find to divide into both 4 and 12 is 4. So that's part of your GCF. Now they both have x's, so x is definitely common. However, we are going to choose the lowest power of x that exists in both. That's a safe way to go. So if this was reverse distributive, it's almost like you're dividing this 4x out of that. Well, that's going to leave you with x squared. I know this is a fact because 4x times x squared is 4x to the third. That sign is not going to change. Divide a 4x out of a 12, well, you'll be left with 3. So that's your final answer right there. So what I'm going to do is I'm going to box it because that's where you should stop. However, there's a lot of students that like to practice and make sure. This times this, that's 4x to the third. 4x times that is minus 12x. So yeah, that's like your check. Make sure you don't say that this is your answer. That's just check. This is the answer. All right, head on over to this part. Same thing. 25, 30, 15, all divisible by 5, and that's the largest I could think of. Now they all have x's. The lowest power of x that we find is x squared. So that's part of our GCF. And then we're going to think about removing 5x squared from all of these. So if a 5x squared is removed or divided out, here you're left with 5x squared. Removed from here, you're going to be left with minus 6x. And removed from here, you're going to be left with positive 3. That's it. All right, so you want to do a quick check? That's a good idea. Multiply this times this. Boom. This times this is 30x third, and this times this is 15x squared. So that's GCF style factoring. We also encountered factoring difference of perfect squares. So in class we say DOPS as a shortcut for that. But notice, you know the square root of x squared, you know the square root of 49, and it's a different sign in the middle. That's how I know it's this style. Therefore, when they say product of conjugate pairs, that means they're going to be perfect matches, except one is going to be plus and one is going to be minus. This is like an automatic setup for a DOPS style question. All right, square root of x squared, x. Automatic first slots. Square root of 49, 7. That goes in the second slots. That's it. That's how DOPS works. As long as you pick it up right away, you can do it that way. To check for this, you would have to do either the multiplication box, FOIL. Either way, you get this to multiply back into this. Now, head on over here, same thing. If it's a DOPS and you know the square root, and you do, you know the square root of this, and there's a minus sign in the middle, automatic setup for 1 plus, 1 minus. Square root of 4x squared is 2x. First slots. Square root of 81 is 9. And you're done. So DOPS is a very, very straightforward style. All right, head on down to number 3. They give us trinomials, 1, 2, 3 terms, so that's a trinomial. And we're going to factor into the product of 2 binomials. Remember, product means multiply. So, product of 2 binomials, that's when we get this set up going like this. Okay, so this is kind of like a reverse FOIL. Okay, and I say give a little note here. Notice that the a value is 1. That means in front of x squared is a 1. When this is the case, we can look for numbers that multiply to be 20, but add to be 9. I don't want to get too far ahead of myself. Let's make sure that I make this x squared happen. So x times x gives us this x squared. So we're set there. So now I'm thinking of numbers that multiply to make 20. Well, things that multiply to be 20. 1 times 20, that's always a desperate case. 10 times 2. 4 times 5. Yeah, I think I just found it. The ones that add up to 9, 4 plus 5 is 9. Both positive. Plus 4, plus 5, and that is our answer right there. Okay. Head on over here to this one. Same thing, a value is 1, so we can look for numbers that multiply to be negative 21, but add to be 4. So we can guarantee this x squared by putting an x here and an x there, and then we start thinking of numbers. So on the list of things that multiply, make a negative 21 that are going to add up to 4. Let's see. Listen, negative 21 and positive 1, that's a desperate case. I don't think it's going to be that. Never going to get those to add up to 4. But negative 3 and positive 7 are very interesting. I think that's it. Negative on the 3, positive on the 7. That's it. Minus 3 plus 7. So, those are the easiest kind of trinomials. And that only works if the a value is 1. This next section here, the a value is not equal to 1. So when you look in front of x squared, I got a 3. In front of this x squared is a 10. These are kind of a pain in the butt. So I really lean on reversing FOIL to get these into binomials. So what I'm going to do, I'm going to set up some binomials here. And I'm going to have to guarantee that this calculation could happen. Well, there's not a lot of things that you can make a 3x squared with. You can use 3x times x, and really, that's it. So we put a 3x here, put an x here, and you're guaranteeing me that's going to happen. So for FOIL, I know that works. Now for the last to work, I'm going to skip over the outers and inners. Trust me. I'm going to focus on this negative 7. Well, things that multiply to make negative 7. Let's make a little list here. You can go negative on the 1, positive on the 7. Or you switch it. You can go positive on the 1 and negative on the 7. But that's it. There's nothing else that multiplies to make a 7. So one of these is the answer. And you're going to put them in there. Now, which way do they go? Well, honestly, I don't know. And I won't know until I try it. That's what I call it, trial and error. So right now, I know the first works and the last work. I'm just going to check these outers. Those outers right there multiply to be negative 3x. I'm going to check these inners, these inside terms. They multiply to be 7x. Oh, I'm off the screen. There we go. And that right there adds up to a positive 4x. And that is just not the middle term. That's how I know that this is just not the answer. So hopefully you have an eraser. I'm going to erase those two. And I'm going to switch the order because it matters. I'm going to put the 1 here and the 7 there. All right, so that was not it. All right, check the outers now. Negative 21x. Check the inners now. Positive 1x. Now that right there is going to add together to make negative 20x. What's the middle term? Done. So you guaranteed me the first, you guaranteed me the last, and I know for a fact that the outers plus the inners makes the middle term. That's how you handle that kind of question. All right, so a little bit of a pain in the butt. So I'm going to do the same process here, and you're going to have to guarantee me I can multiply to make 10x squared. So 5x times a 2x multiplies to make 10x squared. That's a check. Things that multiply to be a 12. Now watch out for this. Minus plus pattern, that's one pattern that we can key in on. Is always going to be minus minus, always. Because negative times negative is positive. All right, things that multiply to make a 12. Well, you got 3 times 4, 6 times 2, 12 times 1. Again, the 12 times 1 seems desperate. So I'm going to try the 3 and the 4. And which order do I try them in? I'm just going to try. Because I never know until I check the outers, in this case, which add up to, or multiply to make negative 15x. And the inners multiply to be negative 8x. Now that right there adds up to negative 23x. Did I get it? I did. All right. Now I happen to be lucky. I could switch the order, and in fact, I could have been unlucky. All right, turn the page. All right, now when you see this factor completely, that means that you're going to factor at least twice. Factor at least 2 times. Okay, now you got to make sure you try GCF first. If you want to make your life easy, look for common factors first. So something that divides into all these, 7. No x, it's not common. So we'll remove a 7 from here, you got x squared. Remove a 7 from there, plus 3x, and remove a 7 from 70. So that's factored 1 time. Take a look at this trinomial right here. That can be factored again. That can be 2 binomials. So guarantee me this with x and x. Things that multiply to be negative 10, well, I'm going to say positive 5 and negative 2. They add up to 3. And listen, that 7 right there, it's got to be part of your answer. We factored twice. I did a GCF followed by an unfoil, and now that's done. So again, different question. Try GCF first. Take a 5. They both are divisible by 5, and they both have an x, the lowest power x. 5x removed from here is going to leave you with x squared minus 4. So again, that's one level of factoring. They want you to do at least 2 levels. Hopefully you see that's adopts. You know the square roots. So you're going to go 1 plus 1 minus. Square root of that is x. And square root of 4 is 2. And don't forget that 5x is still part of your answer. And you are done there. All right. The last couple are just multiple choice. Which of the following is the greatest common factor? All right, so numbers that divide into 18, 30, and 12. Well, 6 is the biggest number I could think of that divides into all 3. Matter of fact, there's only one answer with a 6 in it. Choice 2. The lowest power of x is x to the first, so yes. The lowest power of y, it's common, is y squared. Just make sure. All right. Number 7. Which of the following is the correct factored form? Well, you can check all of these. You can FOIL them all together, or you can just try it. All right, guarantee me 2x squared. So you put a 2x and an x. And we need to guarantee a negative 28. So let's go with positive 7 and minus 4 and check the outers. Those outers are negative 8x. The inners are positive 7x, which adds up to negative 1x. And the middle term, negative 1x. Okay, so that looks like choice 4. And the final question of the day. Which of the following is not correctly factored? Watch out, it says not. Okay. Now, if it's factored correctly, you should be able to do the distributive property and get this. 24x squared, yes, this is looking good. If you check this one here, that times that, you have 24x squared. 4x times 10x is 40x squared. That doesn't have a square on it. So this right here looks like it wouldn't work. All the other ones, if you distribute, it leads you back to that answer. Only one doesn't work. That's choice 3. All right, that's all there is to it. Have a nice day, guys.